B.A Geography, Semester 6, Module 2, Contributing Disciplines of GIS. Objectives. In this chapter, we will get to understand the different disciplines for the GIS. Contributing disciplines, relation of traditional disciplines with GIS, the 4 M's of GIS, exploring global change with GIS. Introduction. GIS is convergence of technological fields and traditional disciplines. GIS has been called an enabling technology because of the potential it offers for the wide variety of disciplines dealing with spatial data. Many related fields of the study provide techniques which make up GIS. These related fields emphasize data collection while GIS brings them together by emphasizing integration, modeling and analysis. Thus, GIS often claims to be the science of spatial information. The list of contributing disciplines can be classified according to heritage, data collection, data analysis, data reporting. The contributing disciplines for the evolution of GIS Burrow 1998 are Geography, Cartography, Remote Sensing, Surveying and Photogrammetry, Computer Science, Technology, Mathematics and Statistics. Geography is broadly concerned with understanding the world and man's place in it. Geography has a long tradition in spatial analysis and provide techniques for conducting spatial analysis and a spatial perspective on research. GIS technology provides a central location to conduct spatial analysis, overlay data and integrate other solutions and systems. When built on a database rather than individual product files, GIS enables engineers to easily manage, reuse, share and analyze data, saving time and resources. GIS has a foundational home in geography. Everything that happens in our state, in our town or city, our country, religion, state, country and continent. Therefore, we cannot get away from the location issue and consequently cannot get away from how the things that are happen may or may not affect us. Geography is vitally important in our everyday life and understanding the geography around us is essential. Cartography is concerned with the display of spatial information. It is now the main source of input data for GIS maps and has a long tradition in design of maps, which is an important form of output from GIS. Remote sensing is becoming an important source of geographical data by providing digital images derived from space and the air. Remote sensing provides techniques for data acquisition, processing anywhere on the globe at low cost and consistent update potential. While integrated with GIS, remote sensed imagery can be merged with other data at GIS providing real-time spatial information. The first part of this book enlightens the concept and the potential utility of remote sensing, surveying and photogrammetry. Providing quality data on positions of cadastral objects like land parcel and building and topography, aerial photogrammetry deals with photographs taken by an aerial camera on the board of aircraft at different altitudes. Aerial photogrammetry is one of the most powerful data capturing techniques for creation of GIS spatial database. The relevant data can be extracted from the aerial photographs of various scales and may be used as input for GIS. Digital orthophotos provide the source of digital data. These products are scanned air photos that are being rectified to eliminate displacement caused by variable elevations of the ground surface and the tilt in the camera. Properly registered with an other digital data sets. These images can be used directly as backdrops for vector data or to provide a base map for on-screen digitalization. The user may abstract information on the land use, vegetation type and other aspects of the landscape from the photograph. Geodesy provides source of high accuracy potential control for GIS. It concentrates on placing objects accurately on global context. Computer science. Computer assisted design (CAD) provides software, techniques for input data, display and visualization and representation, particularly in 3 dimensions. Advances in computing graphics provide hardware and software for handling and displaying graphic objects. Database Management System (DBMS) contributes methods for representing data in digital form and procedures for system design and update. Artificial intelligence (AI) uses the computer to make choices based on availability of data in a way that is seen to enhance the human intelligence and decision making. Using AI, computer can act as an expert in such functions as designing a map, generalizing map features and classification. Mathematics. Several branches of mathematics, especially geometry and graph theory, are used in GIS system design and analysis of spatial data. Statistics is used to build models and perform spatial data analysis in GIS. Statistics is also important in understanding issues of error, quality and uncertainty in GIS data. GIS has many alternative names used over the years with respect to the range of application and emphasis as listed. Land Information System (LIS), AM/FM, Automated Mapping and Facilities Management, Environment Information System (EIS), Resource Information System, Planning Information System, Spatial Data Handling System. The ability to store data on the feature unique layers permits the simple production of special feature maps. In a GIS, spatial entities have 2 characteristics, namely the location and attributes. Coordinate, street address, etc. can give the location and attributes and describe some characteristics of the feature being analyzed. Geographic feature specific activities such as mapping, engineering, environment, resource and agriculture. Cultural or social activities such as market research, census, demographics and socio-economic studies. The switch from hard copy maps to computerized GIS has provided many benefits. This system can help to do the following: store and easily update large amount of data, sort and store spatial features called entities into thematic layers. Data are stored in layers so that complex spatial data can be manipulated and easily analyzed efficiently by layers, rather than trying to deal with the entire database at the same time. Zoom into sections of the displayed data to generate additional graphics which may be hidden at default scales. Query item of interest to obtain tables of attribute information that may have been tagged to specific points of interest. Analyze both entities and their attribute data using sophisticated computer programs. Prepare maps showing selected thematic layers of interest. One can update maps quickly as new data are assembled. Import stored data, both spatial and non-spatial, electronically from different agencies and thus save the cost of collection data. Use the stored data to prepare maps at different scale for a wide range of purposes. Build and augment a database by combining digital data from all the data gathering techniques, that is from surveying, remote sensing, map digitizing, scanning and from the internet. Create new maps by modeling or reinterpreting existing data. The 4 M's of GIS. They are mainly 4 key activities that any urban planner or scientist or resource manager and other geographic information for. They observe and measure environmental parameters and develop maps which portray characteristics of the earth. They monitor changes in our surroundings in space and time. In addition, they model alternatives of action and process operation in the environment. These 4 activities are measurement, mapping, monitoring and modeling, termed as key activities which can be enhanced by the using information system technologies through GIS. Figure explains these 4 M's. GIS technology is more different from traditional mapping and map analysis. GIS is based on mathematical framework of primitive map analysis operation analogous to those of traditional statistics and algebra. From this perspective, GIS forms a toolbox for processing maps and fundamental concepts for spatial measurement. It provides a foundation for advanced analytic operations involving spatial analysis and measurement. Most of the GIS contain analytic capabilities for reclassifying and overlaying of maps. Any GIS system for the measurement of areas, distances, angles and so on require 2 components, namely a standard measurement unit and the measurement procedure. Another major function of GIS capability is the study of environmental surroundings and the monitoring of environmental parameters. Burrow et al. 1988. Although analytical models have been linked to GIS for spatial measurement and resource assessment, the cross-fertilization between the modules of modeling and measurement and automated mapping allows the GIS users to monitor the environment and the earth system. In principle, it is possible to make a clear distinction between GIS and digital cartography. Mapping technology or digital cartography deals with map features and with associated attributes of color, symbology, name of annotation, legends, neat lines and not arrows. GIS includes the capabilities for strong editing and handling the relationships of attributes with spatial entities along with the capability of digital cartography. A map, an ultimate product of digital cartography or GIS, is very persuasive form of data display, and computer drawn map carries the authority of a powerful technology. GIS applications now span a wide range from sophisticated analysis and modeling of spatial data to simply inventory and management. They also dictate the development directions of much of the industry. However, several vendors have chosen to concentrate on the niche market for environmental application and to emphasize support for environmental modeling. GRASS is a significant public domain GIS software developed by USA with substantial capabilities for modeling. Exploring global change with GIS. Maps have traditionally been used to explore the earth and to exploit its resources. GIS technology, as an expansion of cartographic science, has enhanced the efficiency and analytic power of traditional mapping. Now, as the scientific community recognizes the environmental consequences of human activity, GIS technology is becoming an essential tool in the effort to understand the process of global change. Various map and satellite information sources can combine in modes that stimulate the interaction of the complex natural system. Though a function known as virtualization, a GIS can be used to produce images, not just maps but drawings, animation and other cartographic products. These images allow researchers to view their subject in ways that literally never have been seen before. The images often are equally helpful in conveying the technical concepts of GIS, study subjects to non-scientists, adding the dimension of time, the condition of the earth surface, atmosphere and subsurface can be examined by feeding satellite data into GIS. GIS technology gives researchers the ability to examine the variation in earth processes over days, months and years. As an example, the changes in vegetation through a growing season can be animated to determine when drought was more extensive in a particular region. The resulting graphic and known as a normalized vegetation index represent a rough measurement of plant health. Working with two variables over time would then allow researchers to detect regional differences in the lag between a decline in rainfall and its effects on the vegetation. GIS technology and the availability of digital data on regional and global scale enable such analysis. The satellite sensor output used to generate a vegetation graphic is produced by the Advanced Very High Resolution Radiometer AVHRR. This 28 sensor system detects the amount of energy reflected from the Earth's surface across various bands of the spectrum for surface areas of about 1 square kilometer. The satellite sensors produces images of a particular location on Earth twice a day. AVHRR is only one of the many sensor systems used for Earth surface analysis, GIS and related technologies. Will help greatly in management and analysis of these large volumes of data, allowing for better understanding of terrestrial processes and better management of human activities to maintain world economic vitality and environment quality. Summary: many disciplines can benefit from GIS technology. An active GIS market has resulted in lower cost and continual improvements in the hardware and software components of GIS. These developments will result in a much wider use of the technology throughout science, government, business and industry. The GIS application include public health, crime mapping, national defense, sustainable development, agriculture, rural development, natural resources, landscape architecture, archaeology, regional and community planning, transportation and logistics. GIS is also diverging into location based services (LBS). LBS allows GPS enabled mobile devices to display their location in relation to fixed assets, nearest restaurant, gas station, police station, mobile assets, friends, children, police car, or to relay the position back to a central server for display or other processing. These services continue to develop with the increased integration of GPS functionality with increasingly powerful mobile electronics such as a cell phone, PDAs, laptops, web mapping. In recent years, there has been an explosion of mapping application on the web such as Google Maps and Live Maps. These websites give the public access to huge amount of geographic data with the emphasis on aerial photography. Some of them like Google Maps expose an API that enable users to create custom application. These vendor applications offer street maps and aerial satellite imagery that support such features as geocoding, searches and routing functionality. 27 some GIS applications also exist for publishing geographic information on the web that include MapInfo's MapExtreme, Intergraph's GeoMedia Web Map, ISRI's Mac IMS, Arc GIS Server, Autodesk Map Guide, the open source Map Server.